Hi there, Joshua here. So I was teaching rounding the other day, and it was actually making me a bit depressed. No, it was making me a bit depressed. Yeah, I ended up thinking to myself, rounding a decimal to a whole number, I can't see the point anymore. So let's get on with the lesson. Right, so welcome to this lesson on similar shapes. So before I talk about similar shapes, I'm just going to talk about how you enlarge a shape, which is useful for this topic. So when you enlarge a shape, you just multiply all the sides by the same number. It could be any number. It could be 2, could be 3, could be 100. The number you multiply the sides by is called the scale factor of enlargement. So let's say I wanted to take this shape and enlarge it by a scale factor of 2. That just means multiply all the sides by 2. So, and keeping the angles the same. When you enlarge a shape, the angles don't change. So we're just going to end up with a bigger rectangle over here. This side is going to become 6, and this side is going to become 10. So you're just going to end up with a much bigger rectangle. 6, 6, 10, 10. Let's enlarge this L shape by a scale factor of 3. Scale factor 3. That just means multiply all the sides by 3, again keeping the angles the same. So we're going to end up with a bigger L shape basically. These two sides are going to become 6 times 3, which is 18. So 18, 18. These two sides here are going to become 2 times 3, which is 6. So 6 and 6. And these two sides are going to become 4 times 3, which is 12. So 12 and 12. Now, when you do an enlargement, pairs of sides in the same position, like this side and this side, are called corresponding sides. I'm going to be using that word quite a lot. It just means sides in the same position. So another pair of corresponding sides would be this side and this side up here. Now, also, when you do an enlargement, you're not actually changing the shape. The shape sort of stays the same, you're just changing the size. So these two rectangles, they're not drawn to scale. But if they were, you'd see they were the same shape. In other words, when you do an enlargement, you're not changing the ratio of the sides. All the ratios sort of within the shape stay the same. So for example, here the ratio of width to length is 3 to 5. Here it's 6 to 10. 6 to 10 is the same as 3 to 5. So when you do an enlargement, the shape stays the same, it's just its size changes, that's all. Now, when you do an enlargement, you're not allowed to multiply one side by one number and another side by a different number. That's not allowed. So I'm not allowed to multiply this side by 2 and get 6, let's say, and then multiply this side by 3 and get 12. That's not allowed. That's not how you enlarge a shape. So this rectangle here is not an enlargement of that one. And because it's not an enlargement, these rectangles are actually not the same shape. They're different shapes. This is a much sort of thinner rectangle. This rectangle is a lot more square-like. So when you enlarge a shape, you need to multiply all the sides by the same number. There has to be a common scale factor. Right, so let's talk about similar shapes now. So two shapes are similar if one shape is an enlargement of the other one. That's all it means. So two shapes are similar if one of them is an enlargement of the other one. So going back to the first two shapes, these two shapes are similar shapes because this one is an enlargement of that one. It's an enlargement scale factor 2. These two shapes are similar shapes because this shape is an enlargement of that one, scale factor 3. But as I said, these two shapes are not similar because this one is not an enlargement of that one. So another way to talk about similar shapes is to show that two shapes are similar if they've got the same angles and also every pair of corresponding sides has the same scale factor. Right, so this lesson is going to be about finding the missing sides of similar shapes. So I've got a couple of questions here and we're going to find some missing sides of similar shapes. So the first question is, here are two similar shapes. So that just means that this shape is an enlargement of that one. In other words, the sides are related by a scale factor. Every pair of corresponding sides has the same scale factor. And the question is, find x, find this side here. So what you can do, one way to solve it, and I'm going to show you two different methods. One way to solve it is you can just find the scale factor. So you find a pair of corresponding sides that you know. So for example, this side and this side. 3 and 12, and from that you can just see what the scale factor is straight away, because what do you multiply 3 by to get 12? It's 4. 3 times 4 is 12, so we know straight away the scale factor is 4. So you can write that down. The scale factor is 12 divided by 3, which is 4. So then what's x going to be? Well, to get x you just do 5 times 4. So x is just going to be 5 times 4, which is 20. That's one way of doing it. Another way of doing it, which is going to be useful for some of the harder problems we do later, is to set up an equation. Basically, because the two shapes are similar, in other words, because this shape is an enlargement of this shape, every pair of corresponding sides sort of has the same ratio. So in other words, the ratio of this side and this side is the same as the ratio of this side to this side. So we can say that x divided by 5, which is the ratio of these two sides, is the same as 12 divided by 3, which is the ratio of these two corresponding sides. So you can say x over 5 equals 12 over 3. So you're setting up an equation, and to solve the equation you want to get x on its own. To get rid of the 5 down here, we just multiply both sides of the equation by 5. And you end up with x on its own on the left-hand side equals 12 over 3 times 5. And 12 divided by 3 is 4, and then 4 times 5 is 20. So you get the same answer. So this method will be useful for harder problems that we'll do later on. Right, let's do this question down here. So again, we've got two similar triangles, which just means that this triangle is an enlargement of that one. In other words, basically every pair of sides has every pair of corresponding sides have the same scale factor. So the sides of this one are related by a scale factor, and the sides of this one are related by the same scale factor. Right, I'll do that again, because that didn't go so well. Right, let's do this question down here. Again, it's about two similar shapes, two similar triangles this time. We've got to find x, which is this side down here. Remember, similar just means that this shape is an enlargement of that shape. So there will be a scale factor that relates the sides of this shape to the sides of this shape. Method one method you could use is just find the scale factor. That's the method we did over here. To find the scale factor, you need to find a pair of corresponding sides that you know, that have been given, like 4 and 5. And to work out the scale factor, you need to think, what do you need to multiply 4 by to get 5? Well, to work that out, you can just do 5 divided by 4. So the scale factor is just 5 divided by 4. You can leave it as a fraction, but as a decimal, it's just, well, it's 1 1/4, so it's 1.25 as a decimal. Now, how are we going to find x? Well, to go from the big triangle to the small triangle, we need to do 8 divided by the scale factor this time. So x is going to be 8 divided by 1.25, which is, if you do that on the calculator, you get 6.4. 6.4. Let's also have a go at doing it this way, seeing if we get, see if we get the same answer. It's good to know more than one method. So using this method, we can set up an equation. Remember, this shape is an enlargement of that one, which just means that every pair of corresponding sides is in the same ratio. So the ratio of this side to this side, which is x over 8, is the same as 4 over 5, which is the ratio of these two sides. So we can say x over 8 equals 4 over 5. I could have written that the other way round. I could have said that 8 over x equals 5 over 4. But it's easiest to find an unknown if it's on the top of the fraction. So which is why I've done it that way round. So we set up the equation. To get x on its own, you just got to multiply both sides of the equation by 8. So x equals, you're just left with x on that side, and on this side you've got 4 over 5 times 8. Now when you multiply a fraction by a whole number, only the top gets multiplied by 8. The denominator will stay the same, and that's because you can think of 8 as 8 over 1, if you write it as a fraction. So 4 times 8 is 32, and 5 times 1 is still 5. So you get 32 over 5, which is the answer. If you do that on the calculator, if you want a decimal answer, on the calculator you should get 6.4, which is what we had over there. So of course it's the same answer. So a couple of different methods there for finding missing sides of similar shapes. Right, so now I'm going to talk about similar triangles and why triangles are a sort of special shape when it comes to this topic. If I wanted to draw two shapes with the same angles that were not similar, That's not too difficult to do. I could just draw, for example, two rectangles, like I did at the start of the lesson. At the start of the lesson I drew two rectangles, one had sides 3 and 4, and the other one next to it had sides 6 and 12. These two rectangles have the same angles, of course, because they're all 90 degrees, but they're not similar shapes. This rectangle, in other words, is not an enlargement of this one, because there's no common scale factor. To get from 3 to 6 you multiply by 2, to get from 4 to 12 you multiply by 3. So you can draw two shapes with the same angles that are not similar shapes. But with triangles, however, if you try and draw two triangles with the same angles, so let's say I want to draw two triangles with the same angles, so I make these two angles the same, and I make these two angles the same, and I make these two angles the same. As long as I make the angles the same, the triangles will automatically be similar. In other words, I've forgotten what I was going to say. Yeah, the triangles will automatically be similar. In other words, it's impossible for them not to be similar if they've got the same angles. So if two triangles have the same angles, then they will always be similar triangles. In other words, this triangle here will always be an enlargement of that one, if the angles are the same. That's not true of other shapes generally. For example, these shapes here, they've got the same angles, but they're not similar. But with triangles, if two triangles have the same angles, that means they will always be similar triangles. So you might get a question about triangles where they don't mention the word similar. They might just say, here are two triangles with the same angles, and the question will expect you to know that because they've got the same angles, that means that the triangles are similar. So for example, this question over here, it says these two triangles have the same angles, find x, which is this side here. Notice the word similar hasn't been mentioned, but because the question says the triangles have the same angles, that means they've got to be similar triangles. Remember, if two triangles have the same angles, it's impossible for them not to be similar, basically. So we know from that information that these triangles are similar. In other words, this triangle is an enlargement of that one. So when you see same angles, if it's two triangles, you can think to yourself, well, same angles, that means the two triangles must be similar. Similar triangles. So to find x, I guess we can just use the methods we used before. Again, I'll go through both methods for finding x. One method is just to find the scale factor that gets you from, say, 3 to 7. So the scale factor is just going to be 7 divided by 3. So the scale factor is 7 divided by 3, 7 over 3. You can leave it as a fraction or as a decimal. If you do 7 divided by 3 on your calculator, you get 2.3 recurring. And then to find x, you just do 5 times the scale factor. So x is just 5 times 7 over 3, or 5 times 2.3 recurring, which is 11.7 to one decimal place. Let's do the other method as well, which was setting up an equation. So because this triangle is an enlargement of that one, it means all the corresponding sides are in the same ratio. So we can say that x divided by 5 is the same as 7 divided by 3. So x divided by 5 is 7 divided by 3. Remember, when you're setting up this sort of equation, you want the unknown to be on top. It's easier to solve if the thing you're trying to find is on the top of the fraction. So, and to get x on its own now, you just multiply both sides by 5. So x equals 7 over 3 times 5. And 7 times 5 is 35. So you just end up with 35 over 3. And if you do that on the calculator, 35 divided by 3, you should get the same as we got over there, 11.7 to one decimal place, 11.7. Right, let's do this question down here. So again, it's about two triangles. It just says find x. It doesn't mention similar shapes at all. But again, if we can show that the two triangles have the same angles, then we'll know that they're similar triangles. So there are a couple of missing angles here. So let's find the missing angles in each triangle. Well, in this triangle here, you've got 90 and 30. That adds up to 120. So how far away from 180 is that? Well, it's 60 away. So this angle's got to be 60. And in this triangle, these two angles are 60 and 90. So how far away from... So they add up to 150. To get to 180, you have to add 30. So this angle must be 30 degrees. So notice that these triangles have the same angles. because they've got the same angles and they're triangles, that means they've got to be similar triangles. If two triangles have the same angles, then they have to be similar triangles. It's impossible for them not to be similar if they've got the same angles. Remember, that's not true for other shapes. You can have two shapes with the same angles, like two rectangles, that are not similar. But with triangles, if they've got the same angles, they're definitely similar. So in other words, this triangle is an enlargement of that one. So to find x, I think I'll use method 2 actually. I think I'll use this method here, setting up an equation. Because this is an enlargement of that one, the corresponding sides are all in the same ratio. So we can say that x over 12 equals 5 over 6. So x over 12 equals 5 over 6. And then to get x on its own, just multiply both sides by 12. So x equals 5 over 6 times 12. If you think of 12 as a fraction, if you think of it as 12 over 1, you can actually cancel the 12 and the 6. So you can divide them both by 6 and get 2 and 1. So you basically end up with 5 times 2, which is 10. So x is 10. Right, let's do some harder questions now with similar triangles. Right, let's do some harder questions now involving similar triangles. So let's say you're given this question and you're asked to find x. Now, how many triangles can you actually see in this picture? Well, there are actually two triangles. There's triangle ABC and there's triangle ADE. And actually we can show quite easily that these triangles are similar triangles. It's to do with the fact that these lines are parallel. If I was to say which angle in the big triangle is the same as this one, well, it's the angle at D. It's the angle up here, because these two angles are corresponding angles. We've got two parallel lines here. If I was to say which angle in the big triangle is the same as that one, well, it's the angle at E, point E. It's over here. Again, because these two pairs of angles are corresponding angles. And finally, this angle is common to both triangles. So you can see that both triangles have the same angles, therefore they're similar. In other words, the big triangle is an enlargement of the small triangle. And that's how we can find x. So what I do always in this situation is I draw the two triangles out. So I draw the small triangle ABC here, and I draw the big triangle ADE over here. I'll just label the corners so you can see what I'm doing. ACB, ADE. I'll just mark the angles with their colours as well so it's clear what's going on. Right, let's put down any measurements that we know. So the small triangle, this side AC is 5 and BC is 4. On the big triangle, AE is 7 and ED we're trying to find x. So we just use similar triangles now. Which method am I going to use? I think I'll use maybe method 1, just finding the scale factor. So you find a pair of corresponding sides, the 5 and the 7. So the scale factor is just 7 divided by 5, which is, again, you can leave it as a fraction or as a decimal, it's 1.4. So to get x, you do 4 times the scale factor, 4 times 1.4. 4 times 1.4, which is 5.6. So that's how you do it. Let's do another one over here. I'm going to put the unknown in a slightly different position. Let's do x, 7, 6 and 2. So again, because of these parallel lines, these two, the small triangle here and the big triangle here are similar triangles. These two angles are the same, they're corresponding. These two angles are the same up here, they're corresponding angles, and this is a common angle. So the two triangles are the same. I'll just draw them down here, and that will help us to work out what x is. I'll just draw the small triangle and the big triangle. Again, marking the, just colouring the angles so you can see what I'm doing. So on the small triangle, this length is 7, and this length is 6. And on the big triangle, I should really have drawn this a bit bigger, but on the big triangle, this length, what's this length here? Well, it's 2 plus 6, it's 8. And this length here Well, an expression for this length is x plus 7. This length is x plus 7. Right, let's use method 2 for finding x now. Let's use the setting up an equation method. So because the shapes are similar, that means all the pairs of corresponding sides have the same scale factor, they're in the same ratio. So x plus 7 divided by 7 equals 8 divided by 6. So we can write x plus 7 divided by 7 equals 8 divided by 6. 8 divided by 6, you could simplify that, that's just the same as 4 over 3. And then to get x plus 7 on its own, you just multiply both sides by 7. So x plus 7 equals, well, 4 over 3 times 7 is 28 over 3. 28 over 3. Just multiply the top by 7 and leave the denominator alone. And then you just take away 7. So x equals 28 over 3. Take away 7. 28 over 3 is 9.3 recurring. So if you take away 7, you get 2.3 recurring, or just 2.3 to one decimal place. So 2.3 to one decimal place. So that's those ones done. Right, as a bit of a bonus, I just thought I'd do one more, a bit like the other two, but maybe slightly harder, just because x is in a different position. It's very similar to the other two. You've got actually you've got two triangles in this picture, and because the lines are parallel, the two triangles are similar. I mean, they share this common angle. These two angles are the same because they're corresponding. These two angles are the same because they're corresponding. So the triangles are definitely similar. So to find x, again, I'll draw the two triangles out separately. So the small triangle and the big triangle there. So let's put the measurements we know on the small triangle. This is 5 and this is x, what we're trying to find. This is 11 down here. And this side, what's an expression for that side? Well, it's x plus 4, isn't it? It's x plus 4. There's an expression for that side. So notice x is on both triangles now. That's what makes it a tiny bit harder. But let's use method 2 to set up an equation. Remember, these two triangles are similar, which means that every pair of corresponding sides have the same scale factor, is in the same ratio, in other words. So we can say that that divided by that equals that divided by that. So x plus 4 over x, which is the ratio of these two corresponding sides, has got to be the same as 11 over 5. We know that because the two triangles are similar. So what you can do now is you can do something called cross-multiplying. You may not have seen this before, but basically you can multiply both sides by x, and the x sort of goes from this side and ends up on that side. So it sort of goes over there. And you can multiply both sides by 5, and the 5 goes over there. So it's doing two steps in one go, multiplying by x and multiplying by 5. Gets rid of the fractions, and each denominator appears on the other side. So on the left-hand side of the equation, you'll have 5 times x plus 4. And on the right-hand side, you'll have 11 times x, 11x. And then you just expand the bracket on the left-hand side. So you get 5x plus 20 equals 11x. Take away 5x from both sides, so you've got 20 equals 6x. And then just divide both sides by 6. So I'm just going to switch sides around as well. So x equals 20 over 6. And that's, if you do that on a calculator, you get 3.3 recurring. So it's just 3.3 to one decimal place. So 3.3. That's a bit of a harder example there. Right, so here are the last two examples for the lesson. Now these examples are quite different from the last three. Because you don't have a triangle within another triangle. You've just got two triangles, sort of like connected at one point. And we've got two parallel lines here. That sort of ensures that both triangles have the same angles, so they are similar triangles. You can show quite easily that both triangles are similar. By the way, we're going to find x. So you can show quite easily that both triangles have the same angles, because the big triangle down here and the small triangle up here. Which angle in the big triangle is the same as that one? Well, it's not that one, it's actually this one. Because these two angles that I'm shading in red are alternate angles. They sort of form a sort of Z shape, like that. So they're called alternate angles, and this one are also alternate angles as well. And these two angles are the same. They're called vertically opposite angles. So when two lines cross, the opposite angles are equal. So both triangles have the same angles, therefore they're similar. In other words, this triangle is an enlargement of that one. Now what I'm going to do is I'm going to draw them separately underneath, and I'm going to rotate this one round so it's facing the same way as this one. So I'm going to rotate this one round like that. So A will move over here, B will move over here, and C will move up here. Just colour the angles in so you can see what I'm doing. And A is like this. And I'll just copy the other one. This big triangle, let's copy it down here. So E is still there, D is still there, C is still there. And just mark the angles. There we go. And I'll just put the measurements I know on the triangles. So BC is 5, which is now over here. AC is 4, which is over here. And on the big triangle we've got CE is 8, and CD I'm calling X, and that's what we're trying to find. Let's use method 2 to find X. Let's set up an equation. So again, this triangle is an enlargement of that one. So every pair of corresponding sides is in the same ratio, sort of has the same scale factor. So we can say straight away that x over 4, which is the ratio of these two sides, equals 8 over 5. So x over 4 equals 8 over 5. And then you can multiply both sides by 4, and you get x equals, well, 8 times 4 is 32, so you get 32 over 5. And 32 over 5 is just 6.4. We may have had those numbers before actually, 6.4. Let's do one more over here. Let's say this side is, I'll say this side's 10, this side's 35, this side's 50. Let's say this side's x. This is going to be the last example now. It's very similar to this one. It's just sort of this one on its side. Again, we can easily show these two triangles are similar. Because of these two parallel lines, that ensures that the two triangles have the same angles. This angle is the same as this angle. They're alternate angles. This angle is the same as that one. They're alternate angles, and these two angles are vertically opposite angles. So again, just like before, the two triangles are similar because they've got the same angles. I think I'll rotate, not sure which one I'll rotate round actually. Maybe I'll rotate the small one round again. So I'll just have it like this. So I'll put x, x is now over here, and 10 is now over here. I've rotated it 180 degrees. Just colour in the angles again so you can see what I've done. So I've just imagined in my mind rotating the triangle 180 degrees, like that. And I'll just draw the other one next to it. 35, 50. Just colour in the angles so you can see what's going on. There we go. So again, now we can work out x because we know the two triangles are similar because they've got the same angles. I think I'll use method 1 here because it's quite easy to see what the scale factor is. I'll just find the scale factor. The scale factor is just 35 divided by 10. 35 over 10, which is 3.5. So to get x, you just do 50 divided by 3.5. X equals 50 divided by 3.5, which is, I think it's about 14.3 or something like that. Is it 14.3? I should have worked that out before. I don't have a calculator on me, but I think it's about 14.3. It's 14 2/7 anyway. So, that's it.